Alright, so you'll notice on this one there's no graph. It's got a big open blank space here. And they're asking us this question, what are the zeros for? And then they give us a function there. So we first got to have to define, what are they talking about when they say the zeros? Well, so there's a couple different ways that we say this. You know, you look back on number 6, what they asked for is they asked for the x-intercepts, so that when we solved it, that's all we were finding is where does the parabola cross the x-axis. So that's what they're asking here. They're just using a different word. So these words all mean the same thing. So if I ask for the x-intercepts, or if I ask for the zeros, that means exactly the same thing. Why do they say 0? Well, think about what is the y value right here. Oh, well, it's equal to 0, right? Because it's not above the x, or it's not below the x, it's right on the x. So the x-intercept, the y value, is always going to be 0. It's not going to have any height. So x-intercept 0. So another word they might use is the roots. You might kind of think of roots, you think of roots like of a tree, the base of a plant. So I almost kind of think of this as where if the parabola were a plant or something shooting out of the ground, the root, right, is kind of the base. So that's another idea that we can kind of think of there. And so these words, these are all synonymous, right? Synonymous means just different words that mean the same thing, which is just, hey, what's the solution, right? So they might interchange those words, but they all mean exactly the same thing. So what we said a moment ago is that, well, there's two things we can do. If you want to solve, you can factor, or you can use the formula. On this one, for me personally, factoring ends up being a little bit less work. So I always like to see if I can factor it first. So let's see if we can factor it. So there's my A, there's my B, there's my C. And then remember the way this thing works, A times C, and then B on the bottom. Well, so 3 times negative 2, that would give you a negative 6. And then our B is a plus 5. Now remember with the factoring, the way this works is we're looking for two numbers that multiply to the top, and we want those same two numbers to also add up to the bottom. So let's think about ways that you can multiply to 6. First thing that might jump to your mind might be 2 and 3. And then you're like, oh, okay, because 2 times 3 is 6, 2 plus 3 is 5. But wait a second, right? So that's a negative 6. So then you think, oh, well, maybe I just make that one negative. Well, so now that works for the top, but now I got to see if that works for the bottom, and it doesn't, right? Because 2 minus 3 would give you a negative 1. And then you think, oh, okay, well, maybe I make that one negative and that one positive. Well, again, it doesn't work for the bottom. Now I have a positive one. So this is a kind of a trial and error thing. So don't be discouraged if the first numbers that pop into your mind don't work. That's okay. We'll just try something else. So we tried 2 and 3. Another way we can make 6 would be 6 and 1. So let's say if I did 6 and 1, and then I'm like, okay, wait, I got to make one of those negative. I look at the bottom. If I have more positives, that must mean the bigger number is positive. So since 6 is positive and bigger, or since it's bigger, it's going to be positive. So we'll say 6 and negative 1, and that actually does check out. All right, so then I've got x plus 6, and I've got x minus 1. Right. Now there's one additional step on this that you have to be careful of. So don't shoot right into pulling these two things apart and then solving for x. Don't do that. Because there's one extra step to this one, which is the fact that this one had an a value. Take a look at what a is. A is equal to 3. So what ends up happening is that the way that this works is that we have to divide by a, whatever a is. So in this case, a is 3, so I have to divide each one of these by 3. Why are we dividing by a? That's just the way this little machine works, right? So think of this little tool as something we use for factoring. So part of it is because we multiplied by a in the beginning, so now we're kind of backing that out by dividing it. You might wonder, well, why on the last one we didn't divide by a? Well, what was your a value? Well, in this case, your a value was 1. So had we divided by 1, we would have got exactly the same thing, so it wouldn't have changed our problem. However, dividing by 3 here does make a difference, right? 6 divided by 3 doesn't give you 6, it gives you 2. And on this one, you're like, so that doesn't divide evenly, so what am I going to do with that? Well, we have a little trick for that, which is that if you can't divide it, the rhyme coming, if you can't divide it, slide it. So what that means is that this number then becomes the coefficient in front of x there, since we can't divide that evenly. So that would become 3x minus 1 equals 0. And then I can pull this apart, and now I can solve. So we'll do x plus 2 equals 0, and then 3x minus 1 equals 0. And so we get x equals negative 2. And then we're going to get x equals 1/3. So my parabola, what my parabola would look like, and I'm not actually going to go through the trouble of graphing it by hand and finding the vertex and all that stuff like what we did on the last one. But if I were to graph it, what I would see is that my parabola would cross the x-axis at these 2 points. Now I do kind of want to check my answer though. Like I don't want to do all the work that we did on this one, but I do want to check my answer. Problem with using Mr. Old TI-84 here is that his picture quality is from like 1984. Yeah, you see that it's all pixelated. So I want to show you an alternative to using the TI-84. And what that is a website called Desmos. There's also an app for your mobile device, but I'll show you the web-based. This is just a lot nicer, neater, cleaner graph. I'll show you real quick. If you just Google Desmos, let's just type in the equation. And again, what we're doing, we're not cheating, we're just checking our answer. So our equation was 3x squared plus 5x minus 2. So 3x squared, I'm just typing this in on my computer here. It has a little keyboard down here, so 3x squared, right? That's how you do the exponent. Also, the thing I like about this too is that right away you see what happened is if I just have y equals 3x, I've got a line. Notice what happens here the second I throw on the exponent, and specifically squaring it, right? That turns it into a parabola. So something to the first power, right? If you just have an exponent of 1, you got something linear. The second that you throw a 2 up there, now I have a parabola. And you notice, by the way, that it's at 0, 0. Remember we talked about mom, is that mom starts at 0, 0, and it's only if you throw in other numbers that she gets moved down, up, left, right. So let's throw in those other numbers. So plus 5x minus 2. So plus 5x. So you notice she moved to the right, or I'm sorry, to the left. And then minus 2, and you notice that she moves a little further down. So what I'm checking here, by the way, is I could do a couple things. I could check the vertex. You notice the vertex is not a whole number. I get a decimal. I notice we said earlier that the last number is always your y-intercept. Oh, okay. Well, the last number is a negative 2. Look at what my y-intercept is. And then I want to see the roots. Where does it cross? So it looks like it crosses it at negative 2 and then 0.333. Well, what did we get? We got negative 2 and 1/3. Now 1/3 as a decimal, right? Like if you typed this in, if you wanted to do, well, what's 1/3 as a decimal? You get 0.333 repeating, which is why we see a 0.33 there, right? So so you can use the TI-84 to check this. To found the vertex and then to find the zeros, the x-intercepts on this one, using Desmos is just so much faster. And also, too, like I said, I can kind of scroll in, and I can scroll out, I can change the zoom, whereas changing the window on this can be much more cumbersome, can be much more work. So this is a really nice thing. And again, there is an app for your mobile device as well. All right, so that covers number 7. So go ahead and stop here and try number 7 on the right.